Good morning. Now we are going to discuss about control system engineering module 3. So stability analysis. So in stability analysis we are going to discuss about the concepts of stability. So what is meant by concepts of stability? So this is a topic we are going to discuss now. First one, what is meant by stability? So in stability in control system refers to the ability of the system to return to a steady state after a disturbance. So after a disturbance the state system return to its original state. So there is a steady state, that is known as equilibrium. So that is the ability of the system. So we are going to determining the ability of the system. And mathematically a system is BIBO state. So there is BIBO state means there is bounded input that leads to bounded output. If every bounded input produces a bounded output, so that is the mathematical expression of the stability. If a system is stable, any small disturbances like noise, external input, so dies out over time. And next one, if the system is unstable, disturbance grow and lead to oscillations, divergence or failure. So based on the system disturbances stability, so it performs the different outputs. So based on if the system is stable, it can dies out over time, and if the system is unstable, it can produces the oscillation, divergence and sometimes failures. Next, what is the importance of stability? So what is the importance of stability in control system? Means there is safety purpose. So first one, unstable system can cause accidents, so aircraft crash, power grid collapse. So this is the unstable systems. So for these purposes only we are going to analyze the stability of the system and performance. So the performance means stability ensures predictable and reliable operations. So the predictable and reliable operations can be performed by analyzing the stability of the system. So let us discuss about some real-time examples of stability. First one, car suspension. So that absorbs the road shocks and returns to the equilibrium state. So based on the road conditions, the car suspensions can be work up and down. So this is in normal system. So after the normal condition and normal roads, it comes to the returns to the equilibrium position. So this is one of the example for the stable system. And what is unstable system example? Means a bike without balancing, so that falls if disturbed. So this is the real time example of the unstable condition. And next one, there is marginally stable system. So what is my marginally stable system? Means there is ideal pendulum without friction. So ideal pendulum without friction, that oscillates indefinitely. So these are all the different example, real time examples of the stability and what is the importance of stability. And next one, this is the graph for stable system, unstable system and marginally stable system. So in the graph which shows that in the stable system the output decays to steady value, and in unstable state the output diverges. So that is keep growing until they reach the position. And in marginally stable system, the sustained oscillations of constant amplitude is given. So based on this the stable system, unstable system is diverges, and stable system that decays, and marginally stable system that is oscillations occurs. So these are the examples for a stable system. And now we are going to discuss about types of stability. So there are different types of stability is there. First one, there is absolute stability. So in absolute stability means that is system is absolutely stable. So that means if all the poles of the characteristic equation lies in the left side of the S plane. So left side we are considering the graph sheet. So all the poles of characteristic equation lies in the left side of the S plane. So this is known as the absolute stability. There is no oscillations of increasing amplitude. And examples for absolute stability is first order RC circuit with negative real pole. So this is example for absolute stability. And next one, that is relative stability. So relative stability indicates the degree of stability rather than just stable or unstable. So in relative stability, the poles further left faster decay and more stable. The poles closer to imaginary axis gives a slower response and less stable. And examples, so based on the location of the poles in the graph, so that is farther left. So in left side of the graph means it is more stable, and in the poles is located exactly in the imaginary axis means it is less stable. For example, two stable systems, one responds quickly, that is higher relative stability. Next one, that is conditional stability. The system is stable only for certain parameter values. So for example, gain, feedback, so for certain parameters, so for certain conditions we are applying, for certain conditions only the system is stable. So that is known as the conditional stability. If parameter exceeds a critical value, poles shift into right hand side of the system. So that is unstable system. For example, for the conditional stability of the system is oscillator, feedback amplifier with a limited gain margin. So these are the example for the conditional stability of the system. And next one, that is final, that is marginal stability. So marginal stability, so based on the location of the poles we are classifying the stabilities of the system. So finally, that is marginal stability. The poles lies exactly on the JW axis. So JW axis means that is imaginary axis. So in marginal stability, the output is sustained oscillations of constant amplitude. Here no decay and no growth occurs. Example for marginal stability is ideal LC circuit, so that oscillates indefinitely without damping. So this is example for the marginal stability, and this is the graph for location of the poles in the system. For example, in first graph shows that stable system. In stable system, all the poles are left half plane. All the poles are in left half plane. In unstable system, so that is second graph, in unstable system at least one pole in the right half plane, remaining are in left half plane. At least one poles in the right half plane means there is unstable system. And in marginal stable system, the poles on exactly on the JW axis, that is imaginary axis. The poles exactly located on the imaginary axis means that is considered as the marginally stable system. And relative stability, so in relative stability, the comparison of poles further left, so that is more stable versus closer. So the poles located most of the left side means, so that is considered as the more stable state, and that is much more closer to JW axis means, that is imaginary axis means, that is considered as less stable system. So based on the location of the poles, the system can be classified as stable, unstable, marginally stable and relatively stable. And the characteristic equation, that is for the closed loop system, there is 1 plus gs into h of s equal to 0. The root of this equation, so that determines the stability. And the polynomial form is, that is a suffix 0 s power n plus a suffix 1 s power n minus 1 plus going on to 0. So this is the characteristic equation of the stability analysis of the system. And next one, that is pole location and stability. So based on this, already we have discussed that left hand plane, the poles in left hand plane, the system is stable, and right hand plane, the right of plane, the poles, that is system is unstable, and imaginary axis, that is marginally stable. And the frequency domain interpretation, the stability relates to natural the stability of the system that can relate to the natural frequency and damping factor of the system. Pole position determines oscillatory behavior and decay rate. So based on this, we can classification of the system based on the pole location, the stability of the system can be analyzed. And finally, there are some questions for this. So first one, define stability in control system, and what is the difference between absolute stability and relative stability. And the next one, that is state the conditions for BIBO, bounded input and bounded output in the stability. And what happens when pole lies in the right half of the S plane. And what is meant by marginal stability, and give an example. Distinguish between stable and unstable system in terms of pole location. Define conditional stability with one example. And what is the significance of damping ratio in stability analysis? And write the characteristic equation of closed loop control system. Why is stability important in control system design? So try to answer these questions. Thank you.